Hi guys, this is day 24 of the A2 Economics Revision Challenge, and today we are doing production in the short run. When we look at production in the short run, we first want to define what we call a production function. The production function is simply a function that shows the relationship between inputs and output in a production process. So for each different combinations of input, the production function basically tells us the maximum quantity of output a firm can produce over some period of time. So when we change our inputs become, let's say, more labor intensive or more capital intensive, the production function is telling us basically how much output will we achieve from this substitution of labor and capital or any other factors of production. Now, when we look at production in the short run, we say some factors of production like labor or land or capital could be fixed, while other factors can be what we call variable. Now, typically, labor is assumed to be a variable factor in the short run, while land or capital can be fixed in the short run. So what do we really mean by fixed versus variable factors? Fixed factors for us are those factors which remain constant regardless of quantity of output. So even though your quantity of output goes up, the fixed factor remains constant. So for example, in a case where we are increasing our output, let's say a school case, a school is increasing its output, which is number of students, and the building does not change in the short run, that will be what we call a fixed factor. But let's say in order to increase our output, we need to increase our faculty, that will be what we call a variable factor. So what is a variable factor? Variable factor is the factor that changes in quantity as output changes. In fact, we change that variable factor to achieve more output for us. So variable versus fixed factor means that variable factor is a factor that changes as quantity goes up, while fixed factor remains constant as quantity goes up. And for us, short run is defined as a period where at least one factor of production is fixed, which means all other can be variable. So we need to make sure that we understand this definition, because when we're looking at short run, we mean to say one or more factor can be fixed. If all factors are variable and not fixed, we then say that means that we are in the long run. So in the short run, at least one factor of production is fixed. In the long run, all the factors of production are variable, and we say sometimes in the very long run, all factors of production are variable, even technology, which can also change in the very long run, because we could have what we call inventions that can take place in the very long run that can change the technology as well. When we look at production now in the short run, we will define basically three concepts here. In the short run, we look at what we call total product or total output. We look at marginal product, which is the extra output that we produce, that we get when we hire an extra worker. I'm going to look at it very closely in a little while. And we also look at what we call average product. Total products, we say it's TP, marginal product is MP, and average product, of course, will be AP. So let's define all of them. We say total product is simply the total or the maximum quantity of output that we can produce with our given combination of inputs. So if we have a given combination of input like labor and land in a particular quantity, how much is the maximum we can get? That's the total output from those inputs. While marginal product could be for a factor, let's say marginal product of labor will be the additional output that I can get when I hire one more worker. So how much extra output that I get when we get to hire one extra unit of let's say a variable factor, that can be, for example, labor. Now mathematically we say this, that marginal product is simply change in, let me write this, MP is simply change in TP, which is change in total output, divided by change in the quantity of labor that we are hiring, and that's why it's the contribution in terms of output by an incremental or extra worker. Now this brings us to the next concept, which is what we call average product. I'm going to talk about these in diagrams in a little while. Average product for us is simply the ratio of output to the number of units of labor. So in other words, average product is simply change in it's TP over Q, which is the output per worker. Now what we now try to do is basically see how TP and AP and MP behave in the short run and give reasons of why this behavior takes place. So let's start off with talking about total product first. When we draw a diagram for total product, we look at the relationship between the total product or total output with the quantity of the variable factor that we are employing. So as we employ more labor, how will my total output behave? Well, the argument will be that when you are increasing your variable factor, so this is my quantity of labor that I am employing more and more, and this is my total output. As I get more labor to work for me, my total output should go up, and that's true, total output does go up. But what we realize is that total output actually goes up in a different fashion as we add more labor. In fact, for the first few workers, total output will go up much faster, and then total output goes up much slower. So this is basically, whenever we draw a graph like this, this is when output is rising or something is rising at a faster rate. This is when something is rising at a slower rate. So what we see here is just that initially total output will rise at a faster rate, then total output would rise but at a slower rate. And there could also be a possibility that total output after some point start to even fall. So that's how my TP looks like. We say the first part, when total output is rising at a faster rate, let's call it for Q1 workers, and then when total output starts falling, we call it Q2 workers. So when total output is rising for the first Q1 workers, we call this as increasing MP. And I'm going to talk about it in 1 minute. This is called increasing MP. And then when total output starts to sort of rise slowly or increase at a slower rate, we call it diminishing MP. And then when TP is falling, we call it negative MP. So let's talk about these three zones. Well, increasing MP is simply the idea that when you are hiring more and more of your labor in the first few sort of units of labor, they are doing two things better. Number one, the reason why output rises at a faster rate is because of two reasons, or why is increasing MP happening or output is rising at a faster rate is simply because number one, workers are utilizing capital better. What do we mean by this? The idea goes this, that if we have capital which requires, let's say, more than one worker, so as you keep on hiring more and more workers, the utilization of capital becomes better. So for example, if I have a machinery that requires 4 workers but I only have 1 worker, then 1 worker may not be utilizing capital better. Second thing that happens, which results in output to rise at a faster rate, is simply the idea that when your output is rising at a faster rate, that can also happen because of what we call better specialization that takes place. people start to specialize in one thing or the other, and initial specialization results in improvements of output. Now, the reason why we call it increasing MP when it's a total product graph is because when you're going to look at from 0 to Q1 workers, I'm going to go back to the diagram. When you look at 0 to Q1 workers, and let me also get rid of this diagram. So when you look at 0 to Q1 workers, the output is rising, we say, at a faster rate. Now, what that means would be that for 0 to Q1 workers, these are Q1 workers, and let's say this is Q2 workers, and this is my MP now, marginal product. Remember, we said is the incremental or increase in my total extra output when I hire one extra worker. So what is happening is simply that for the first Q1 workers, my MP is rising, and then the next Q1 to Q2 workers, my MP is falling, and then for Q2 workers, my MP is actually negative. And the reason why we say this is because if I want to find the slope of this graph, the slope of this graph will be change in Y over change in X, which will be change in TP over change in Q of labor. Now, change in Q of labor, change in TP over change in Q of labor simply means that we're looking at, if you go back to the formula that we established for MP, we're looking at MP to be change in TP or change in Q of labor, which means MP is simply the slope of TP, which means MP tells us the rate at which, let me write this, it's the rate at which TP is changing. And that's exactly what we see here, is just that for the first Q1 workers, TP is rising at a faster rate because of MP going up, because every worker that we are hiring is bringing on an extra unit of output. Then on, TP is rising at a slower rate, MP falls because every extra worker is probably bringing less and less output, which means my total output is rising but rising slowly. But when extra workers start to bring negative output, which means doesn't bring but in fact affect output, my TP will fall. And we've said this, that reason why TP is initially rising at a faster rate is because of the idea that let me write this, rising MP or increasing MP is better, increasing MP, and the reason why this increasing MP is taking place to start off with is the idea the workers are probably utilizing capital better, or they're doing better specialization, which means that they are specializing and doing tasks which is making the output to go up. But there is a room to specialization. There is a point when after which specialization will stop giving benefits. But also importantly, we say that there is a reason why the diminishing MP takes place or falling MP takes place, and this is what we call law of diminishing returns. So diminishing MP, let's talk about the law of diminishing return. According to the law of diminishing marginal return, the principle says is that in the short run there are some fixed factors and other variable factors. So let's say if we keep on increasing the variable factor in the short run to increase more output, in the short run the fixed factors somehow get more and more divided in the use by the variable factors. What do we mean by this? Well, look at this. Let's say labor is the variable factor and capital is the fixed factor. So when you keep on adding labor to the capital, each labor will get less and less of capital to work with. So in other words, what we say is this, that the capital to labor ratio, starts to fall. And that capital being the fixed factor, so it's fixed, and the labor is the variable factor, so you keep on adding labor. So as we increase the variable factor, each factor will get less and less of the fixed factor. And that's basically where what we'll see is this comes a point where the productivity of that variable factor may not be as high as the one before it. So diminishing MP starts to rise, or total product or total output starts to rise slowly because the variable factor will start to get less and less of the fixed factor. So the idea goes this, that because of the fixed factors in the short run, because by definition short run is where some factors are fixed, others are variable, because of the fixed factor in the short run, there is a law of diminishing marginal return takes place, where each variable factor gets less and less of the fixed factor. The productivity of the variable factor will be lower than the factor before it, which had more of capital to work with, and that results in ultimately MP to start falling and TP to start rising slowly. Remember, the law of diminishing MP is a physical law and not an economic law, though we use it in economics, but that's the way it is, that the fixed factor is making the variable factor's productivity to get affected. Then comes a point when the MP becomes negative. So this is where the third zone we're looking at. The third zone is negative MP. Hopefully we'll stop at that point, but let's say when your MP becomes negative, so there's a negative MP, there is a negative MP. This is where what we say is that our TP is falling. Basically, at that point, each variable factor is adding less and less of capital to each variable factor is actually giving us a negative contribution, and that's why total output will start to fall, and that's why we would probably like to stop at Q2 than to move forward and make MP to become negative. This is how our MP looks like. So initially it rises because we need to we utilize the capital better and there is better specialization. Then MP starts to fall because of the law of diminishing return, as the capital to labor ratio starts to fall because labor is rising, capital is fixed, so the capital to labor ratio starts to fall, and then comes the negative MP. And the last discussion now would be on AP. Now when we draw AP is like this. So if I draw my MP curve, my MP was rising and then falling. This is my MP, right? So this is quantity of labor, and this is MP comma AP, because I'm going to draw AP as well. My AP curve looks like this. It's going to rise and then it's going to meet my MP curve, and as soon as it meets the MP curve, it starts to fall. This is how my AP looks like. And why is that? So, well, to know what is happening here, I'm going to sort of see three things happening. Number one, when the MP is above AP is rising. So let me write this. When MP is above AP rises. Number one. Number two, when MP is below AP falls. That's also something which you see here. When the MP curve is above AP rises. When MP curve is below AP falls. And number three thing we see is this, that MP meets AP at AP's maximum point. So I want to explain all these 3 points. That comes a lot often in MCQs as well. So whenever the marginal is above the average, it pulls up average. Why is that? So for example, let's say for each test that you have, you score more than your average, you will pull up your average. Let's say every time you give a test, you do better than your average, you will always pull up average. Every time you do worse than your average, when MP is below AP, when margin is below average, so every time you do worse than your average, you will pull down average. So that explains the first and the second point. When you do better than the average goes up. When you do worse than the average goes down. So when MP is above AP, it pulls up AP. When MP is below AP, it pulls down AP. MP is simply the extra output from each worker, while AP is the average output. So when MP is above AP, AP rises. When MP is below AP, AP falls. And then comes this point X, which is where what we say is this, that when MP is above AP, AP rises. But as soon as MP meets AP, after which MP will go below, AP starts to fall, then therefore MP should meet AP at AP's maximum point, because beyond X, AP will fall. Before X, AP was rising. Therefore, at X, AP must be at its maximum point. So that's why when MP meets AP, AP is at its maximum point. So just to quickly recap, the most important sort of discussion here that we've done is the law of marginal product, which is something which will build our cost chapter in all of the chapters. And the law of marginal return happens because in the short run some factors are fixed and others are variables. Those that are fixed become a constraint and therefore become a problem and can affect productivity. Productivity will not be as high as we keep on adding workers, because at some point the fixed factor will become a problem. This may not be a problem in the long run, but at least in the short run we have this problem.